Hi everyone and welcome back to NTE. My name is Tabi Singh and on this channel I create quality revision videos as requested by you. If that's something you're interested in, then please consider subscribing. Before we begin with today's lesson, I'd like to say thank you to all my new subscribers. I really do appreciate it. Welcome to the NTE family and I hope you enjoy your stay. Alright. So today I've decided we're going to do the February-March 2018 paper. This is question 4 from that paper. And the reason why I've decided to do this is because if you've been following the channel for quite some time, you'll know that under the functions section, the only thing that we've done so far is the linear function and the quadratic function. And very recently someone contacted me and asked me to please do graph interpretation. And this is very nice because what this question has done is that it's integrated the quadratic function and the linear function together, and it's asking you to basically solve different things and using your knowledge of both these functions. Okay, it states that below you have the graph of f. So we're given the formula f of x is equals to x minus 4 squared minus 9. So this is obviously our parabola and it's given to us in the vertex form. Alright, so that's given information. And then they tell you that the straight line is the line that the graph G. Okay, fine. Further, they tell you that B and A are the x-intercepts of F. Alright, and E is the turning point of F. C is the y-intercept of both your F and your G graph. So now you have to start thinking about simultaneous equations over there. And then they lastly tell you that the x-intercept of your linear function is at the point D. Alright, and that the line DE is parallel to the y-axis. Okay, that might be useful at some point. Let's see what the first question asks us to do. The first question says, write down the coordinates of E. Right, so the point E is right over here. And if you look at that, that's the turning point of your parabola. The reason why they say write down is because they gave you the vertex form of your quadratic function. You can simply just read off the coordinates of your turning point directly. So the turning point E is simply the point 4 minus 9. Remember, where did I get that? I got that from the value of P and Q. If you go back and just watch the previous video, you'll remember that from this form of the from this form of your quadratic function, your turning point is defined as minus P Q. So you have minus, the P value in this case is minus 4 and your Q value is minus 9. Right, so then this then gives you the point 4 minus 9. And if you look at your Cartesian plane, that makes sense because you add an x value, a positive x value, and you add a negative y value. So the point 4 minus 9 makes absolute sense. Right, let's move on to question 4.2. They now say calculate the coordinates of point A. Okay, so point A is over here and point A is the x-intercept of your quadratic function. Right, to find your x-intercept, you need to set y equal to 0. And because you have a quadratic function, you are going to solve for both the x-intercept at A and at the x-intercept at point B. At point B. You're going to solve for both those x-intercepts. Then what you need to do is you need to now actually interpret the position of point A in order to figure out which of those two values that you're going to get actually belongs to A. Okay, let's start. So from the function f of x, you're going to set f of x equals to 0. So you're going to have 0 is equals to x minus 4 all squared minus 9. Move the 9 to the other side, you have 9 is equals to x minus 4 all squared. Now you need to take the square root of both sides. Remember, taking the square root requires a plus and minus. So you have plus or minus the square root of 9 is equals to x minus 4. Right? Then, therefore, your x is going to be plus or minus the square root of 9 plus 4. This means that x is either equals to, if you're considering the plus sign, then you have positive square root of 9, that will be 3. 3 plus 4 is 7. Or x is going to be, if you consider the negative square root of 9, that will be negative 3, and then negative 3 plus 4 is plus 1. Right. Then now you need to actually answer the question and say that therefore x-intercept A is the coordinate. Now you have x is equals to 7 or x is equals to 1. If you look at the position of A, it's impossible for it to be 7. It's much closer to 0, so it makes more sense for it to be 1. So that's the x position 1 and the y position 0. So that will be your coordinate for A. Alright, let's move on to question 4.3. It says that M is the reflection of C in the axis of symmetry of F. Write down the coordinates of M. Right, let us see. What is the C that they're talking about? Okay, so C is over here. That's the y-intercept of both your F graph and your G graph. And now they're talking about a point M. It's not labeled on this graph, but they tell you that it's a reflection of C about the axis of symmetry. So your axis of symmetry is going to be straight down the x value of your turning point. So that's your axis of symmetry. And since we've already figured that out, we know that this is x is equals to 4. Then if they talk about a reflection, they say that you're now taking this F graph and you're folding it across this line. So you're going to have a point that is going to have the same horizontal line, and it's going to lie over here. This point, they're calling it point M. What they want you to do is to write down, simply just write down, there's no calculations that are needed, the coordinates of M. So from logic, you know that M, seeing that they're in the same horizontal line, it means that they share the same y value. So your y value is going to be exactly the same. And now we need to know what's the y value at the point C, and that's the y-intercept. Okay, we haven't figured out the y-intercept. They gave us the vertex form, so we're going to have to change this to standard form, because standard form is the one that gives you the y-intercept immediately. But maybe that's going to take too long. So to get your y-intercept, you need to make x0. So just substitute. Since they said write down, I'm not going to show any calculation. Basically what you're going to do is you're going to substitute 0 in the formula in place of x and get an answer. So you have negative 4 squared minus 9. That gives you a y-intercept of 7. So the y-intercept will be 7. Okay, that's the y value. And then the x value we're going to calculate from the axis of symmetry. So basically, if you go 4 units backwards. So if you had x is equals to 4, right, that's a distance of 4 away from the origin. And if it's a point of reflection, it means that it's the same distance to the right. So if you go 4 units to the right, so 4 plus 4 will give you 8. And that makes sense because this point M is just a little bit away from the point B. And remember, the point B was at x is equals to 7. So this was x is equals to 7. So it makes sense that this is x is equals to 8. Right, so that would be the coordinates for point M. I hope that made sense. Right, now let's look at question 4.4. So question 4.4. It says determine the equation of G in the form y is equals to mx plus c. Alright, so remember, now we just figured out that the y-intercept, alright, is at the point 0, 7. Right, we just calculated that now. I didn't show you the calculation, but basically that was when I told you to substitute 0 in for the position of x. Or if you really wanted to, no one is going to beat you up. If you really wanted to, you could change this into standard form, and then you would be able to see that the y-intercept is 7 immediately. All right, but you know, we went with the quick route. We just substituted 0 in this formula. We got an answer of 7. So our y-intercept is at the point 0.7, and this is the point C. Okay, so that's the point C over there. All right, now they're asking you to determine the equation of your straight line. Okay, let's analyze the straight line quickly. This straight line is sloping downwards, so we're expecting that the gradient is going to be less than 0. So we're expecting our gradient to be negative. Why? Because we can see that it's sloping downwards, right? And remember, in your straight line formula, the point C is your y-intercept. So I already have that value. So what I already have is y is equals to mx plus 7. Okay, that's what I already have. So in order to calculate m, the only thing I need really is just one other point on this graph, and then I'll be able to calculate m. They tell you that d, I think they tell you somewhere here in the beginning, yeah, that d is the x-intercept over here. So the x-intercept of G is d. Right, so the point D, we know that it's an x-intercept, so it has some x value and a y value of 0. Okay, and luckily enough, the point D also intercepts the axis of symmetry of your quadratic function, and we know that the axis of symmetry lies at x is equals to 4. So the point D is the point 4, 0. Now I can substitute this point D into my already set up equation, so I can call this equation A, right? And I can say substitute, so sub D into A. That's what I can say, right? And then you'll have 0 is equals to 4m plus 7. You'll get minus 7 is equals to 4m, and then that will be then m is equals to minus 7 over 4. Right, there we go. Our gradient is less than 0, which is exactly what we were expecting. Now you can finally write down the equation. So y is equals to negative 4 over 7 x plus 7. So that's the equation for the straight line. Right, let's move on. Question 4.5 now says write down the equation of g to the minus 1 in the form y equals. Okay, g to the minus 1 is something I haven't introduced on this channel, but let's just move down a little bit. Okay, so question 4.5. So g to the minus 1 is an inverse function. So inverse function. There, we haven't gotten there on the channel specifically, but that doesn't really matter. Basically, with the inverse function, what you're going to do is you're going to swap x and y around. That's the first thing that you're going to do. Okay, it's the first thing. And then the second thing you're going to do is you're going to solve for y. Okay, so basically you're going to take your initial equation. So y is equals to minus 7 over 4 x plus 7. Okay, to get the inverse, you swap x and y around. So you're going to have x is equals to minus 7 over 4 y plus 7. Now we solve for y in this new equation. So we'll have x minus 7 is equals to negative 7 over 4 y, right? And then to solve for y, we're going to have to divide both sides by negative 7 over 4. That's the same as multiplying the other side by negative 4 over 7. X minus 7. That's going to be equals to y. We're getting very close. Now multiplying this into the bracket, you get negative 4 over 7x. Negative times a negative will give you a positive. There's a 7 in the numerator and a denominator that will cancel out. So that's going to be positive 4 is equals to y. And then I can just write this properly. So basically, g inverse is equals to, or is equivalent to, they wanted you to write g inverse as y. So you're going to write y is equals to minus 4 over 7 x plus 4. So that's the equation of the line. Right, let's move on to the final question. Question 4.6 is asking you, for which values of x will x times f of x be less than or equal to 0? Okay, so 4.6, they're asking for which values of x will x times f of x be less than or equal to 0. Okay, so what does this mean? They're asking you for which values will this following condition hold. So what you're looking for is that when you multiply the x values and the y values, they have to be less than or equal to 0. Okay, let's go back and check. Okay, let's start over here. Over here, you've got negative x values and positive y values. So for x is greater than 0, so above this, your y values are positive. Can you see that the graph f of x is positive, right? Over there. So if you have negative times positive, the answer is negative, and that's less than right? And there would also be equal to 0 right over here. When is f of x equal to 0? We're here at the x-intercepts. That's when f of x, the y values, are equal to 0. So if you had to think about it, it's between the values of x of a and x of b that if you multiply those x values times the y values, those would be less than or equal to 0. Because if you think about it, for the position A, your x value is 1. So over here, your x value is 1. That would be 1. And then you had to multiply it with f of x. So f of 1 at this position is 0. So that's equal to 0. Right. So it's for all the values in between x is equals to 1 and x is equals to 7. And they both included because that's what creates the 0. Right. So it's for all these values. So it's for all these values in between here. In between x of a and x of b going upwards. Right. Okay. So the answer is this will be met when x is greater than or equal to 1 but less than or equal to 7. Right. Until next time, matriculants,